Hello, my name is Edwin Malera, and I'm a student from CE 315 Computational Methods course at City College, New York. I will be going over web work homework number 2, problem number 1 in this video. This problem has 3 parts. Part A would be to find the absolute and relative error of approximating Euler's number, E, by 2.7183. Part B would be to find the absolute and relative error of approximating 100 times Euler's number by 271.83. And part C would be to find the absolute and relative error of the single precision representation of Euler's number using MATLAB and the command single of exp of 1. Here we have the absolute error and relative error of approximating equations. For the absolute error, we would have to use the absolute value of the computed number, computed value, minus the true value of the number. And the relative error equation, we would have to use the absolute value of the computed number minus the true value of that number, and all would be divided by the absolute value of the true value of the number. Now let's get to the 3 parts of the question. All right, so here we have part A, which we would need to just find the absolute and relative error of approximating Euler's number by 2.7183. And the absolute error equation, as I just mentioned, we would have to assign 2.7883 to the computed value minus the true value, which is Euler's number. And in MATLAB, we would compute it as assigning x to 2.7183 and creating the equation. I called that ABS error, which stands for absolute error, which equals the absolute value of x minus exp of 1. And this just represents Euler's number to the first power. And we go over to the command window, as we would run it first, and we go over to the command window, call out ABS error, and we would get the answer, which is 1.817 times 10 to the negative 5th power. For the relative error, it would be just basically using the absolute error and dividing it by the absolute value of the Euler's number. And we would go over to MATLAB and assign x to 2.783. The relative error equation would be absolute value x minus exp of 1, and we would put all those in parentheses and divide it all by the absolute value of exp1, which is once again Euler's number to the first power. We'll go over to the command window, REL error, as I computed it on my programming, and we would get the answer 6.685 times 10 to the negative 6th power. And once again, all these 2 answers that we would get are the result of the errors that we basically get from using 2.7183 instead of Euler's number. So now in part B, we would have to find the absolute and relative error of approximating 100 times Euler's number by 271.83. And this problem is similar to part A, where we have to assign x. And in this case, I assigned x to 271.83 and named the equation absolute ABS error equals the absolute value of x minus 100 times Euler's number E. And we would go over to the command window and we get 1.8 times 10 to the negative third power. And the relative error, we would have to just basically use the absolute error and divide it all by 100 of E, 100 times Euler's number to get 6.685 times 10 to the negative 6 power for this problem. And now let's go into part C. Part C asks to find the absolute and relative error of the single precision representation of Euler's number. In MATLAB, we would use the command single of exp of 1. And, well, single precision actually means floating number value of 32 bits in the programming, which in this case, it would just make Euler's number be a much more precise number. Um, Basically, a much more precise true value of Euler's number. So we would use the absolute error equation to compute Euler's number minus single Euler's number. And we would compute this by assigning x would be Euler's number, and ABS error would equal to the absolute value of x minus a single precision of Euler's number. And we would get 8.255 times 10 to the negative 8th power. In the relative error section, we would basically divide the absolute error by the absolute value of the single precision of Euler's number. Yes, these are the commands I used. REL error equals the absolute value of x minus single precision of Euler's number, and all over the absolute value of single precision of exp of 1. And in the command window, we would call that out as we get 3.037 times 10 to the negative 8th power. And notice how these numbers, with using the single precision, we would get a much more smaller absolute and relative error for this problem. And once again, my name is Edwin Malera. This was web work and homework number 2, problem number 1. I hope everything was clear and understandable. Thank you.